Hello, in this video, I'm going to explain you the relevant topics of the chapter relation and functions. As you know, a 6-mark question has replaced 4 marks question in this year's examination pattern 2017. So, this chapter became the relevant part of our syllabus. So, we are going to prepare the chapter relation and functions in just few minutes. The topics which are relevant in this chapter are these four. We have the four topics. First is relation. जो रिलेशन में से जो क्वेश्चन आता है वो आता है इक्विवेलेंस रिलेशन का. फंक्शंस में से जो क्वेश्चन आता है वो आता है इनवर्टिबल फंक्शन का. बाइनरी ऑपरेशन में से जो क्वेश्चन आता है वो आता है इन 4 प्रॉपर्टीज़ के ऊपर, कॉम्यूटेटिव, एसोसिएटिव, आइडेंटिटी एंड इनवर्स. एंड 2 मार्क्स का जो क्वेश्चन आता है वो आता है फ्रॉग एंड गॉफ. सो हम सबसे पहले पढ़ने जाएंगे यहाँ पे रिलेशन एंड फंक्शंस में से रिलेशन. रिलेशन में से जो क्वेश्चन आता है वो हमेशा इक्विवेलेंस रिलेशन का आता है. इक्विवेलेंस रिलेशन में हमारे पास प्रॉपर्टीज होती हैं रिफ्लेक्सिव, सिमेट्रिक एंड ट्रांजिटिव. इन 3 प्रॉपर्टीज को हमको सेटिस्फाई करना पड़ता है. इफ ए फंक्शन सेटिस्फाई दीज ऑल 3 प्रॉपर्टीज देन द फंक्शन इज कॉल्ड टू बी एन इक्विवेलेंस रिलेशन. सबसे पहले हम रिफ्लेक्सिव प्रॉपर्टी को समझते हैं. रिफ्लेक्सिव प्रॉपर्टी वो प्रॉपर्टी है अगर ए का रिलेशन ए के साथ है तो हम बोलेंगे कि हमारा रिलेशन रिफ्लेक्सिव प्रॉपर्टी को सेटिस्फाई कर रहा है. सिमेट्रिक प्रॉपर्टी वो वाली प्रॉपर्टी है अगर ए का रिलेशन बी के साथ है तो दिस विल इम्प्लाइज दैट बी इज ऑल्सो रिलेटेड टू ए. एंड ट्रांजिटिव प्रॉपर्टी वो वाली प्रॉपर्टी है अगर ए बी के साथ रिलेटेड है एंड बी इज रिलेटेड विथ सी देन ए मस्ट ऑल्सो बी रिलेटेड विथ सी. Now we are just going to solve the question to understand the properties of equivalence relation more effectively. This is the question. Let me read. Let R be the relation in the set 1, 2, 3, 4 given by R equals to 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3 and 3, 2. These are the elements of relation R. We have to find whether it is a reflexive, symmetric or transitive relation. These are the 3 properties of equivalence relation. First of all, I will check reflexive property. रिफ्लेक्सिव प्रॉपर्टी को प्रूव करने के लिए हमें ये शो करना पड़ेगा कि हर एक एलिमेंट खुद से ही रिलेटेड है. जैसे कि 1, 1, 2, 2, 3, 3 and 4, 4. All the elements should belong to R. Now just check the question. R equals to 1, 1 is there, 3, 3 is there, 4, 4 is there and 2, 2 is there. All the elements belongs to R. Therefore, the relation R is reflexive relation. Now I'm just going to check for the symmetric relation. For the relation to be symmetric, if 1, 2 belongs to R, then 2, 1 must also belongs to R. Now just check. 1, 2 belongs to R. No 2, 1 is there. Therefore 2, 1 does not belongs to R. Therefore we can say that the relation R is not symmetric relation. Now just check the transitive relation. Transitive relation says that if uh, 1 3 and 3 2 is the elements of R, then 1 should also be related with 2, that is 1 2 must also be there. Just check, 1 3 is there and 3 2 is there, and 1 2 is also there. Just check the elements for any couple, for any pair. If 1 is related with 2 and 2 is related with 2, then 1 is also related with 2 for this element. Therefore all the elements of the relation R are satisfying the transitive property. Therefore R is transitive relation also. Thus we prove that the relation R is reflexive, transitive, but not symmetric. Now we take another question to understand the relation reflexive property. This is the question that state the reason why the relation R is such, AB is such that A is less than equals to B square on the set R. R means the set of real numbers is not reflexive. So we just prove solution. Reflexive property says that AA must also belongs to R. So if I take AA is such that A is also less than equals to A square, this property will be satisfied by all the numbers that which belongs to the real number set. This property must be satisfied by all the real numbers because the relation R is defined on the set of R, that is real numbers. So we take the example, let the example is like that, let A equals to 1 by 2. So if we apply the value in the relation, that is A is less than equals to A square, that is 1 by 2 must less than equals to 1 by 2 square. This comes up 1 by 2 less than equals to 1 by 4. So we know that 1 by 2 is always greater than 1 by 4. Therefore A is not less than equals to A square. Therefore we can say that our relation is not reflexive. So I hope you all understand all the three properties of the relation R. You can satisfy all these properties for the equivalence relation in the board examination. So we just move to the next topic, that is functions. First of all, we are going to understand that what type of question comes from the topic functions. One type of question comes from it, that is invertible function. Now first of all we will understand what an invertible function is. To prove a function to be invertible, we have to satisfy two properties, that is one is 1 1 and the other is 1 2. If the function satisfies these two properties, 1 1 and 1 2, then the function is known as an invertible function with an inverse. Okay, first of all, the property that is 1 1, what it is? First of all, we will try to understand the property that is 1 1. 1 1 means every element of domain is related with only single element of codomain. That is, if it is a domain and it is a codomain, here 1 2 3 4, here 1 2 3 4. If 1 has the image 1 and 2 has the image 2 and 3 has the 3 image 4 and the image 4, there is no single element which has two images, or there is no single element which have two pre-images. One element is connected with only single element. Okay? That's why the function is known as 1 1. These type of functions are always known as 1 1, or the other name of the function is injective. 1 1 function is also known as injective function. So we are going to understand the property, how to satisfy the property in the next question. Now just understand what the onto property means. Onto. Now we are going to understand what the onto property is. Onto means no element is there in codomain which do not have any pre-image. That is, if that is the domain 1 2 3 4 and this is the codomain. If 1 is related with 1, 2 is related with 2, 3 is related with 3 and 4 is related with 4. Here 5 element is ideal, that is no pre-image is there for the 5 element. Therefore this function is not an onto function because the element 5 do not have any pre-image. If this also have a pre-image, here all the elements have an pre-image. Therefore this function, now this is onto function. Onto function is also known as surjective function. If a function satisfies these two properties, injective and surjective, that is 1 1 and onto, then the function is known as invertible function or bijective function. Now consider the question, that is, function f is such that this is the domain of the function and this is the range of the function, which means that domain is the positive real numbers and range is -5 to infinity, given y fx equals to 9x square plus 6x minus 5. Here we have to show that function is invertible. Find f inverse x, inverse of the function we have to find, where r plus is the set of all non-negative real numbers, that is positive real numbers. So first of all, to prove the function to be invertible, we have to satisfy the property, that is 1 1 property. To satisfy the 1 1 property, we take that fx1 equals to fx2. We just let. Now put the value x1 in the function fx, 9x1 square plus 6x1 minus 5 equals to, put x2 in the function 9x2 square plus 6x2 minus 5. Here 5 is cancelled out with 5. 9x1 square minus 9x2 square plus 6x1 minus 6x2 equals to 0. Here we take that x1 square minus x2 square, 9 is the common, 6 common, x1 minus x2 equals to 0. Here a square minus b square property can be included. Now we take that x1 minus x2 is the common factor. If we put x1 minus x2 equals to 0, then x1 equals to x2. This is the main target of our 1 1 function. x1 equals to x2 means that we just took two elements x1 and x2 from the domain and we put into the function, then we got the elements are equal, that is x1 and x2 both are the same element, which means that which means that all the elements in function f have a unique image. Therefore, the function is one function. Now we just have to prove the property onto for this function. We are just going to let fx equals to y. Now put y into the function. We just have to use the method of completing the square and evaluate the value of x in terms of y. To applying the completing square method, we are taking 9 as common from this equation. Y by 9 equals to x square plus 6 by 9 x minus 5. Here we are going to have the coefficient of x, that is 3 by 9, and we are just adding and subtracting the square of this 3 by 9. Y by 9 x plus 3 by 9 to the whole square minus 5 by 9 y by 9 minus 9 by 81. Y by 9 equals to x plus 3 by 9 to the whole square minus 81 54. Y by 9 plus 54 by 81 equals to x plus 3 by 9 to the whole square. Here 81 is the LCM, 9y plus 54 equals to x plus 3 by 2 whole square. Here x equals to under root 9y plus 54 upon 9 minus 3 by 9. This is the value of x. This is the value of x. Here we are going to add a line by the ending of this equation. This line will tell us that our function is onto, that is codomain equals to range. We are going to write like that for all values of y or x belongs to R plus, that is our domain. Therefore, fx equals to y. Hence, our function, that is f, is an onto function. As the function is 1 and onto, therefore the function is also an invertible function. Now we have to calculate the inverse of the function. Just write down the value of x we have got from the onto function, 9y plus 54 minus 3 by 9 upon 9. This is the value of onto function. This is also called the inverse of the function. F inverse x equals to 9x plus 54 upon 9 minus 3. This is our f inverse x. I hope you understand this question. This question is of 4 marks or 6 marks according to the pattern of board examination 2017. Just prepare the question in this pattern only. If you like my video, just subscribe my channel for the latest new videos for upcoming chapters. I will tell you about the binary operations in the next video. Just like and share my video.